Hi friends, today we are going to discuss about polarization of light. Today's topic is polarization of light is one of the important topic in the chapter wave optics. Before going to the polarization of light, we know that light is an electromagnetic wave. So we all know that what is electromagnetic wave. In electromagnetic wave, electric field vector and magnetic field vector, these two vectors are perpendicular to each other and perpendicular to the propagation direction. So there are two field vector, one is electric field vector and magnetic field vector, okay, in an electromagnetic wave. So we know that the velocity of light is given by c is equal to E by B. We know that C is equal to E by B. Okay, C is the velocity of electromagnetic wave, that is equal to E by B. E is the amplitude of electric field vector, B is the amplitude of magnetic field vector. Okay, so here we are discussing about light. So light is electromagnetic field vector. So light contains electric field vector and magnetic field vector. But here, based on this equation, we can write E is equal to CB. So in light we consider electric field vector is more than the magnetic field vector. Okay, so E is equal to C by B. So here we consider light is a electric field vector. Light is a electric field vector because E is equal to C by B. The magnitude of electric field vector is equal to the velocity of light into the magnitude of magnetic field vector. So we are considering light as an electric field vector. Light as electric field vector. Okay. In ordinary light, this electric field vector vibration in all direction perpendicular to the propagation direction. So that type of light is called unpolarized light. So ordinary light or light coming from bulb, light coming from sun, all are unpolarized light. That means the electric field vector will vibrate in all directions and perpendicular to the propagation directions. So that type of light is called unpolarized light. Okay. Here we are going to discuss about polarization of light. Okay. So we know what is unpolarized light. So unpolarized light means we know that light is a electromagnetic wave. In that electric field vector is more than compared to the magnetic field vector. In this electric field vector are vibrating in all direction and perpendicular to propagation. So that type of light is called unpolarized light. So ordinary light are unpolarized light. Okay. So the representation of unpolarized light, so this is source, so the vibration will be in all directions. So this is representation of an unpolarized light. So here the vibration will be in all directions. This is from a source of light. Suppose light is propagating, unpolarized light is propagating, that propagation can be represented by like this. This is propagation of unpolarized light is an arrow and a dot. Here dot represents the vibration into the plane of the board, and here this perpendicular to, this is the propagation direction, so both are perpendicular to each other. So it's a up and down arrow, and here the vibration will be into the board. So these are the representation of propagation of an electromagnetic wave, or otherwise propagation of an unpolarized light. So now we are going to discuss about polarization of light. So we know that an unpolarized light consists of vibration in all direction. Suppose this unpolarized light is passed through a certain crystal like calcite or tourmaline. Okay, so unpolarized light is passed through certain crystal like tourmaline or calcite. Okay, it is passed through the axis of the tourmaline or calcite crystal. When the vibration parallel to the crystallographic axis is passed to the crystal, all other vibration is absorbed by the crystal. That means the light coming out from the calcite or tourmaline crystal contain only one vibration. This phenomena is called polarization. So we know that unpolarized consists of the vibration in all direction. When it is passed through certain crystal like calcite or tourmaline, it is passed to the crystallographic axis of this crystal. The vibration parallel to the crystallographic axis is passed through it. All other vibration will be absorbed by the crystal. So the light coming out from the tourmaline or calcite crystal consists of only one vibration. This phenomena is called polarization of light. Otherwise, we can say that when light is passed through a crystal, okay, the vibration is restricted to a single plane, or the phenomena of restricting the vibration of electric field vector in a particular direction when it passes through certain crystal like tourmaline or calcite is called polarization of light. Okay, so we can represent it diagrammatically. So this is an unpolarized light. So this is an unpolarized light. Okay, it passed through a crystal. This is a crystal like tourmaline or calcite crystal, and this is a crystallographic axis. Here XY is a crystallographic axis, and this is the first crystal. Okay, XY. So this unpolarized light is passed through this crystal. So the vibration parallel to the crystal. So here XY is a crystallographic axis. Here these are the vibration parallel to the crystallographic axis, and this vibration is perpendicular to the crystallographic axis. So light coming from this tourmaline crystal contain only one vibrations. Okay, here the vibration into the board is absorbed by the crystal because that is perpendicular to the crystallographic axis. This light is called polarized light. Here this unpolarized light is passed through a crystal. Here XY is a crystallographic axis. So when it's passed through the crystal, the vibration parallel to the crystallographic axis is passed through it, and the vibration perpendicular to the crystallographic axis is absorbed by the crystal. So the light coming out from the crystal consists of only one vibration. So that means the vibration of electric field vector is confined into a single plane. This phenomena is called polarization. So we can again conclude what is polarization. So the phenomena of restricting the vibration of light into a single plane is called, when it passed through a certain crystal like tourmaline or calcite, is called polarization of light. Is called polarization of light. This is the diagrammatic representation of polarization of light. Here this is the unpolarized light is passed through a crystal, we get polarized light. So this is a polarized light. Here one crystal we use to produce polarized light from unpolarized light. So this crystal is called polarizer. This crystal is called polarizer. So what is a polarizer? Polarizer is a device which produced polarized light from unpolarized light. Here in this diagram, when an unpolarized light, this is an unpolarized light, it is passed through a crystal. Okay, this is maybe calcite or maybe tourmaline, and is passed through the crystallographic axis. Here XY is the crystallographic axis. Here the vibration will be confined in a single direction. So this unpolarized light, when it's passed to the crystal, we get a polarized light. So this crystal is called a polarizer. So what does a polarizer mean? A polarizer is a crystal which produces polarized light from an unpolarized light. And this polarized light is again passed through the another crystal. Here, both the axes are parallel to each other. The crystallographic axis of T2 and T1. T1 and T2 are the crystal. Both are parallel. So we get a polarized light. We get a polarized light. Here the vibrations are parallel to the crystallographic axis of T2. So we get the output. So we get a polarized light. And we use another crystal T3. Here we can see that the axis is perpendicular to the crystallographic axis of T1. Here we can see that the third crystal T3, the axis is perpendicular to the axis of T1. So here the vibrations are perpendicular to the crystallographic axis of T3. So no light is coming out. So from this we can prove that the light is transverse in nature. Light is transverse in nature. Here an unpolarized light means the vibration in all direction is passed through the polarizer. We get a polarized light, and is passed through another crystal. Here the crystal axis are parallel to the first crystal, that is T1. So we get a polarized light. And is passed through another crystal. Here the axis of the crystal is perpendicular to the axis of polarizer. So no light is coming out from the crystal T3. So we can prove that light is transverse in nature. Here we are using the second crystal and third crystal, whether the light coming from the first crystal is polarized or not. Or the crystal we use to check whether the light coming from the polarizer is polarized or not. So that crystal is called analyzer. That crystal is called analyzer. So polarizer is a crystal which produces polarized light from unpolarized light. But analyzer is a crystal, it's a tourmaline crystal or calcite crystal. It is used to check whether the light coming from the polarizer is polarized or not. Okay? And when we rotate this analyzer in front of polarizer, we can see that the intensity of light, polarized light, is vary from maximum to 0 and 0 to maximum. When the angle between the axis of analyzer and axis of polarizer are parallel or anti-parallel, parallel or anti-parallel, we get the maximum intensity. When the axis of analyzer and polarizer are perpendicular to each other, so no light will be coming out. So we can conclude that when a crystal, analyzer is rotating in front of a polarizer, the intensity of light coming from the analyzer is vary from maximum to 0 and 0 to maximum. Maximum to 0 and 0 to maximum when both the axis of the polarizer and axis of the analyzer are parallel or anti-parallel. We get a maximum intensity. When the axis of analyzer and polarizer are perpendicular, the intensity is 0. Okay, so we can conclude that when analyzer is rotating in front of a polarizer, the intensity of light coming from it will varies. It is explained by a scientist, malus. That law is known as law of malus. Now we are going to discuss about law of malus. So law of malus explains how the intensity of light coming from the analyzer varies when the analyzer is rotating in front of a polarizer. Okay. The law states that the intensity of polarized light is directly proportional to the square of cosine of angle between the plane of the polarizer and plane of the analyzer. So law of malus says that the intensity of polarized light is directly proportional to the square of cosine of angle between the plane of the polarizer and plane of the analyzer. Suppose I is the intensity of light coming from the analyzer. We can say that I is proportional to cos square theta. Here theta is the angle between the plane of polarizer and plane of analyzer. Plane of polarizer and plane of analyzer.